Hi guys, welcome to this set of videos, and what we're going to be doing here are these videos are going to follow along with the notes that are really going to kind of introduce us to this topic of geometry. Now, this particular set of videos, the next several videos will follow along with the notes that are really going to be about points, lines, and planes. I know I've got here segment length and midpoint, and we will talk about those things as well. We're even going to cover like Pythagorean's theorem and the distance formula, a couple of postulates, which I'll go over with you in a second what those are. But really, this is just going to kind of be our introduction to geometry. And so I'll say a couple quick things about sort of the way that we're going to start all of these video sessions together, the way that we'll start every single one of these lessons, or if you prefer to call it a section. I do have written up here that this would be essentially chapter 1, section 1 of any geometry course. You would start off by talking about these particular things. As we go through these sections, every single section is going to be sort of guided by one essential question, which I have written for you right here. So if you go ahead and take a look at our essential question, what the question is asking is how do, oh, hang on a second, where's my highlighter? There it is. So how do you draw a line segment and measure its length? How do you draw a line segment and measure its length? Here's the idea of the essential question. By the time we get to the end of this set of videos, you should be able to answer that essential question. All right, that's the question that we want you to be able to answer. Now, in order to help you answer that question, what we're going to do is there are going to be several learning targets. I call them objectives. Think of them as tasks, things that you should be able to do that all will help you answer our essential question. So as we go through these videos, as we work our way through this set of notes, these are the things that I'm going to be showing you how to do, the things that we're going to be talking about together that will all help you by the time we get to the end of this first section, this first set of videos. Then you should be able to answer our essential question. So everything's really going to be kind of focused on helping you answer that question. The objectives or learning targets, you can really call them whatever you want to. I'll call them objectives, but these are the things that you'll need to be able to do in order to help you answer that essential question. And so what we're going to do is we're going to take a look at some basic geometric terms. We're going to start there, so I'll talk about that one first, some basic geometric terms and why that's really important. Then what we'll do is we'll talk about students being able to construct a copy of a line segment or a segment bisector. In geometry, constructions are a big part of geometry, and constructions are really just sort of drawings generally done with very simple tools. Almost all the constructions that we'll do in here you can do with simply a ruler and a compass. When we get to angles, you may want to have like a protractor or something like that, maybe to make your life a little bit easier, but you really wouldn't even need a protractor. A ruler and a compass will do most of the constructions that we would do here in this class. And so that's just going to be constructing, that's why we call them constructions, constructing geometric shapes. You can do triangles, you can do angles, you can do line segments, all that kind of stuff. And then, students will use the distance and midpoint formula, both solving it algebraically and using a coordinate plane. So as I said earlier, in this section we'll also cover things like Pythagorean theorem, the distance formula, the midpoint formula, and all of that really is just going back to helping us construct a line segment and, like we said, measure its length, which might require the distance formula or midpoint formula or something like that. Okay, so let's jump right into this. The first thing that we're going to look at is some geometric terms. Consider this. If you're learning any foreign language, any language that is not your native language, it really involves two components to learning a foreign language. You need to not only be able to speak the language, but there also is a component where you would need to be able to read the language, read and write the language. There's kind of two parts to it. And guys, geometry is very much its own language, all right? The language of geometry, and it's going to work the exact same way. There are a lot of terms, all right? There's a lot of vocabulary that is based on what we're going to be doing here in geometry. And so in order for you and I to be able to communicate clearly, you need to know what I mean when I say certain things. What is a line? What is a point? What is an angle bisector? What's a perpendicular bisector? What are corresponding angles? What are vertical angles, right? These are all terms that we're going to learn this year. And it'll be very, very important that you use the proper language so that we can communicate clearly. Not only so you can understand what I'm saying and what I mean by what I say, but also so that you can clearly, if you ever have a question, pose your question to me. It helps if you're able to speak the language of geometry. But just speaking the language of geometry is only one part of it. You also need to be able to read the language of geometry, because we have our own way of writing, sort of how to describe these terms, these geometric terms, by writing them out using symbols and notation and things like that. We're going to look at all of that here to get us started. So right away, just starting us off, we're going to start very, very basic here. Hopefully these are things that you are already familiar with, but how do we do this in geometry? So we're going to start off with points, lines, and planes, and kind of a really important note here, and yes, if you're taking this class with me, these undefined terms, you will need to know them as undefined terms. I will ask you on quizzes and tests, what are some examples of undefined terms in geometry? Now here's what I mean by undefined terms. Think of the word between, all right? The word between does not have a formal definition. You cannot define the word between. However, right, you're thinking, wait a second, that doesn't make any sense. I use the word between all the time. So you could describe to me what it means to be between two people, or to have something between two objects, right? You could describe what the word between means, but the word between does not actually have a formal definition. You can only describe to me what the word means and how you would use it. Exact same thing here, guys. Points, lines, and planes. Those are our three undefined terms. They do not have a formal definition. What's written here is simply a description, and you've got the notes right there in front of you. You can read the description of those three things: a point, a line, and a plane. They are undefined terms. They do not have a formal definition. We're only simply describing what each of them is. What I want to spend my time on is simply this: how do we write these things? Now, the nice thing about the videos is you can stop it, pause it, rewind it, watch it as many times as you need to, so I only have to say things one time, and then you go back as many times as you need to until you are certain that it's clear. Here's the way it works. The way that we're going to write in geometry a point, all points will be given a capital, non-italicized letter name. So for example, the point P. It will not be italicized, and it must be a capital letter. A capital letter, non-italicized. If it's already named, you have to keep the name that it was given. It's just like a dog or a cat that you might adopt from a shelter. Normally they have a name, and the shelter would suggest you should keep the name that it has. The dog is already used to responding to that name, and if you change its name, you'll take it home and it'll wind up peeing all over the floor because it gets confused. All right, same thing here. These points get very confused, and you don't want it peeing on the floor. So if it's already named, keep the name it has. If it's not named, you can name it whatever you want to. Name it after yourself for all I care. As long as you use the first letter of your first name or first letter of your last name, whatever, it doesn't, you can call it whatever you want, but it's got to be a capital letter, non-italicized. For a line, there are two ways to name a line, and you want to watch out for both of them. First of all, on a line, and I want you to just quickly try something for me. If you've got a sheet of scratch paper there with you, I want you to, anywhere on that sheet of scratch paper, just draw a single dot. All right, so all you're going to do is just draw a single dot like I've got right here. Draw a little dot. Oh, sorry, I apologize. That's my highlighter. Oh, scratch that. I want my pen. There's my pen. All right, I'm just going to draw a single little dot. There it is right there. There's my point. Now, I want you to draw a line through that point. And more than likely, those of you who are watching this video, none of you would draw the same line, right? Because I got a couple of options. I can draw a line that goes through that point that is horizontal. I could draw a line that goes through that point that's vertical. You could draw a line that goes through that point that's at an angle, or this angle, or any angle, right? There are, in fact, infinitely many ways to draw a line through a single point. However, if I, on that sheet of scratch paper, anywhere you want to, go ahead and draw 2 points. I have a point there and a point there. And the question is, how many ways can you draw a line through those 2 points? Well, if you think about it for a second, the answer is, there is only one unique line that goes through 2 points. I will draw my line through those 2 points as best I can. Hang on a second, let me see if I can get it right. Oh yeah, I'll take that, that's pretty good. And then, so I draw my line through those 2 points, and then I go back and see, are there any other ways to draw a line through those 2 points? And there isn't. There's one unique way to draw a line through any 2 points. You can only draw one line, and it is unique. There's no other line that goes through those same 2 points. So when it comes to a line, what you could do is you could name the line based on 2 points that are on the line. For example, I have this line right here. I have the point A and the point B. Those are 2 points that are on the line. The points must be on the line. They have to be on the line, and you only need 2 of them. That's more than enough to describe the line. Now, you could use more than 2 points, but that would be a waste of time. You're doing more work than you have to. If you only need 2 points, why would you waste your time finding 3 or 4 or 5 points? You only need 2. So we find 2 points. Remember, points, capital, non-italicized letters. So the point A, the point B, and we can name the line AB, capital, non-italicized letter, and then above those letters we just simply draw a bar with an arrow on each end, indicating that it's a line. Very, very important. You see a bar, arrows on both ends, all right, over top of 2 letters, it's a line, all right, and the line is named by 2 points that fall on that line, okay? Again, line AB is exactly the same as line BA. The order that the letters fall in doesn't matter. You don't have to do the left first and then the right, or the right first and then the left. It doesn't matter. Put the points in whatever order you want to. Again, though, if it's already named, please keep that name. And the second way that you can name a line is if you don't have 2 points, or even if you do have 2 points but you just don't want to write all of that, no problem. We could also name a line with a lowercase italicized letter. So, for example, super original here. I know we've called this line L. All right, it's a lowercase letter, it's italicized. If you see a lowercase italicized letter, it's a line. It represents a line. Okay? Then we come to a plane. Now, a plane is a 2-dimensional, which simply means it's a flat surface. It has a width and a depth. It does not have a height, all right? Just simply a width and a depth, 2-dimensional surface like a sheet of paper or a whiteboard or this television screen, right, represents a plane, right? It's a flat 2-dimensional surface. Now, there are 2 ways to write a plane. You could either use a capital, right now we use capital letters for points. Here's the difference. A point is non-italicized. The plane will be an italicized capital letter. The letter will be italicized. That will represent a plane. That means that is a plane. Or if you find, and it will require 3 points. If there are 3 points that all lie in the plane. Why 3? Well, because 2 points represents a line. I can draw I can draw a line through any 2 points. The only way to encompass 3 points, right, that are non-collinear, simply meaning 3 points that are not in a straight line, right? Obviously, I can't draw a line through X, Y, and Z. A line has to be straight, linear, meaning in a straight line. So X, Y, and Z, the only way to get all 3 of those points in a same plane is to draw a plane. So we could simply call, but points are capital, non-italicized letters. So if you see 3 capital, non-italicized letters, that's going to represent a plane. We'll probably write plane in front of it, but honestly, I don't have to. you should know 3 capital non-italicized letters. I'm naming a plane for you. All right, so those are our undefined terms. Now, what we're going to do with those undefined terms is we're going to use those undefined terms to then help us define a couple other terms. So a few other things that you guys are going to want to know about line segment. The line segment includes the definitions you can see right in here of points, and also a segment, referring to a line. It's just a portion of a line. So again, you can read our definition. Define meaning we can define these terms. We define these 2 terms using the undefined terms above. A line segment has a beginning and an ending point, and then just the line that connects those 2 endpoints. All right, so please do not think of this thing as extending. If this line extended past C to infinity and extended past D to infinity, then I would have the line CD. I didn't ask you for the line CD, I'm asking you for the line segment, just a little portion of a line. And like I said, you absolutely could, extend this in both directions to infinity. But then again, that would be a line then, and we don't want the line, we just want a portion of the line, and that portion of the line I'm asking for is the line segment CD. Now again, these will be named using 2 points. You must use the endpoints, right? You have to use the endpoints of the line segment, so point C, point D, capital non-italicized letters, CD, you could do DC. Fine, same line segment, doesn't matter what order you put them in, doesn't matter. But in order to represent a line segment, we will put a bar, no arrows on either end of the bar, right? It'd just be a bar or a line over the point CD. That should be an immediate flag in the air. That's a line segment. Okay, and then there's array. Array is going to be a portion of a line extending only in one direction. So at one end, you'll have an endpoint. The other end will continue to infinity. Like we have right here, I have the ray PQ. Again, a couple of ways to do this. The ray can extend in either direction. In this case, I just so happen to have the point P being an endpoint. And that ray is extending through Q, but continues to infinity. Again, you'll name the ray based on 2 points on the ray. In this case, though, it will be very important. The order does matter. The order does matter. The endpoint on a ray must come first. And here's the reason why. If you think about it for a second, this does make really good sense. If I have the point P and the point Q, let me draw it again right here, the point P and the point Q. If I draw the ray that I've already got drawn there, starting at P, extending through Q, and going to infinity, there's the ray PQ. Is that the same as the ray starting at Q and going through P? Are those 2 rays the same? Hopefully, your initial sort of knee-jerk reaction may have been, yes, those are the same ray. But actually, if you were to think about it for a second, hopefully you caught this looking at them, they're not the same ray. And why not? Well, yeah, they go in opposite directions. The ray PQ is headed off to what would be your guys' right. The ray QP is headed off to the left. They're going in opposite directions. These are not like a line segment where it doesn't matter which direction you look at it, it's the same. Or a line, doesn't matter which direction you look at it. It's the same. Not true for a ray. All right, so this one would be the ray PQ starting with the endpoint, and what you're going to have is a bar over top of those with an arrow just on one side, as opposed to the ray QP starting with the endpoint and a bar over top of those with just an arrow on one side. With this though, it does not matter, right? I don't have to flip that arrow around and have it pointing. That doesn't matter, right? The arrow will always be pointing to the right, always to the right. But what does matter is what point comes first. The end point has to come first, all right? Okay, so what we're gonna do is we're just gonna flip over to the next page of the notes and we're gonna try a couple of these, all right? So we're gonna head over here one page. And what we've got is, again, like I said, the language of geometry sort of has two things to it. Not only do you need to be able to speak the language, but you have to be able to write or read the language of geometry. And that's what I tell you about right here. Sometimes you'll be written a statement, you'll need to draw a picture, sometimes you'll be given a picture, and you would need to be able to write the statement. Okay, so what we're gonna do here is we're just gonna practice a couple of these where I've written out some things for you. Make sure we know how these go. All right, so here we go. Let's draw some pictures. And again, when it comes to geometry, I would always suggest, I am almost every time going to draw a picture. They're very, very helpful. They really can help you sort of visually figure out what's going on in the problem. Pictures are wonderful. Please draw pictures. You should never feel bad about drawing a picture or having to draw a picture. I will do it. You should do it. All right, and I've been doing geometry for a very long time. In fact, drawing pictures is one of the reasons why I even like geometry. I'm a doodler. I like drawing pictures. And this sort of makes doing geometry worth it for me. So if I have an opportunity to draw a picture, I'm going to draw a picture. Here's what I've got. I want you to draw and label figures for each relationship. P, it is a capital, non-italicized letter. That's a point. Is on, and then I give you 2 points, A, B, and I've got that little bar on top with arrows on each end. All right, so we remember that means I have the line A, B. Here we go. There's point A right there. There's point B right there. I will draw a line through those 2 points. Boom, there we go. And here's what they tell me. P is on that line. Okay, great, I can put P on there. Now, some of you may put P right between the 2 points. That's fantastic. You can put P between the 2 points if you want to, but do you have to? No. There's nothing that says P must be between points A and B. I could put P out here, I could put P out here, I could extend that line as far as you want to extend it and put P clear out there on the far end. Doesn't matter where you put P, so here we go, I'll put P, I don't know, I feel like maybe it should be right there. You could put P wherever you want to. I don't tell you where to put it on the line, I just tell you it must be on the line. It's on the line. Let's go on to the next one. Again, I have a line CD, all right? We're gonna get really good at sort of recognize what these symbols mean. So the line CD, it lies in, ooh, look at that capital letter and it's italicized. Do you remember what that means? Well, I have a line, it lies in capital plane. We have a plane, so I have the plane R, and I have a line that is in that plane. So we'll take a look at how you draw that. And contains F. Capital, non-italicized, that's a point. So I have a plane R, a line CD, and a point F. And if you need to, feel free to draw yourself or write yourself little notes here, right? I know that that is going to be a line. I know that that is going to be a plane. Oh, I don't know why I put a C in plane. Spelling is not my strong suit. Math, got it. Spelling, ugh, yikes. And this is a point. Okay, so let's go ahead and do this. I'm going to start by drawing my plane first. You could certainly just draw a flat sheet. I try to kind of like to give some of my drawings, and this is geometry class, you will never be graded on your drawings ever. You won't ever be. Well, unless it's a construction. When it comes to constructions and you're using a ruler and a compass, yes, you'll be graded on those. But here we go. We're just going to draw ourselves a little sketch. That looks, yeah, you know what? I'll take that. And that's going to be my plane R. So there's my plane R. It's really hard to draw italicized letters, so I apologize. I've drawn the plane, I put the R on it. You should know that that just is plain R. I'll try to italicize things if I can, but it's kind of tricky. I need a line that is in that plane. Okay, cool, I can do that. Here, we'll do my line in blue. Let's just draw a line in there. There's a line, put arrows on either ends, and you gotta get your points on there. It is line C, it is line D, and again, remember, order doesn't matter. I could have made that the point C and that the point D. You would be just fine. That is absolutely accurate. Fine, it's a line. Interchangeable, okay? All right, so the line CD is in plane R and contains F. What contains F? Well, the line CD is in the plane R and contains the point F, which means somewhere on that line, I need to put the point F. This time, yeah, let's do it. I'll put it between those 2 points. There's my point F. So I have my plane R, the line CD is in the plane, and point F is on that line. Okay, here we go. D and E intersect at N. Hey, here's a great one, okay? I've got a capital italicized, capital italicized. Yeah, two planes. I got two planes. I have plane D and plane E. They're going to intersect each other, and they intersect each other, ooh, interesting, lowercase italicized letter. What does that mean? It's a line. It's a line. So these two planes will intersect each other at a line. Let me show you. Let's see if I can do this. Again, drawings are a little tricky. You won't ever be graded, again, with the exception of constructions. You won't ever be graded on your drawings. Let's call that'll be my plane D, and then I'll do another one. Let me see if I can do this in blue. Here we go, here we go, here we go, here we go. Okay, okay, okay. Dotted, and then hold up, hold up, hold up. Okay, all right. Cool, I can live with that. All right, so hopefully you can kind of see, and it'll be a little bit better here in a second. Oh, let me call that plane, that's plane E. All right, here's the way that these are gonna work with planes. Obviously, when you have a flat surface that are intersecting or crossing each other, there's always going to be a portion of the plane hidden behind the other plane, right? So right here I have the plane D, and these guys are intersecting, so let's go ahead and draw our intersection right there. That is the line N, okay? So I have this plane D that is kind of at an angle a little bit, right? And then I have plane N that's cutting through it, right? That's cutting through it, right? Okay, so I've got plane E coming through it, plane R is kind of at an angle to it, and so what happens here, right, is I can see plane D except where plane E cuts through it. So that dotted line there is the portion of plane D that is hidden from view by plane E, and we'll just use a dotted line to show you that that plane is still existing there. It's just if this were a three-dimensional object you could hold and rotate and you held it like that, you wouldn't be able to see that little part of plane D. It'd be hidden by plane E. Same thing right here, right? If you were to kind of hold it, plane D would be hiding that portion of plane E from view. It's still there, and we'll just use a dotted line to represent it. The idea here is this. Whenever you have two planes that intersect each other, they will always intersect at a line. Very important point. Two lines will always intersect at a point. Two planes will always intersect at a line. Let me say it again just to be perfectly clear. Two lines will always intersect at a point. Two planes will always intersect at a line. All right, anytime you have intersecting planes, you're going to get a line. Anytime you have intersecting lines, you will have a point. And I got one more for you here. Let's go ahead and draw this one, and then we can move on to hopefully the rest of our notes. I tell you that A, B, and C are collinear. Collinear simply means A, B, and C are in a straight line. There's A, B, and actually here, let me draw my line through there, and then that way I'm certain to get C on that line. So there we go. I have three collinear points, simply meaning all 3 points are in the same line. Then I tell you, but B, C, and D are non-collinear. Non-collinear meaning B, C, and D are not in a straight line. You cannot draw a straight line through B, C, and D. So all you gotta do, there's B, there's C. Do not put D anywhere on that line, because then they would be collinear. So I'm gonna simply put D, I don't know, let's say up there. But you could have put D down there. You could have put D up here. Could have put D way back over here. Whatever, doesn't matter. Just as long as D doesn't fall on that line, that would make it non-collinear to the rest of them. Guys, we've got a lot more exciting stuff to do here in this first section of geometry as we kind of introduce these things. So head on over to the next page of the notes. I'll meet you guys there.